Okay, so let's classify some images of fashion clothing. Before we start, let's enable GPU execution to speed things up. Now, let's install a library called TensorFlow Datasets, allowing us to use the Fashion MNIST dataset. You can read more about TensorFlow datasets by following this link. Next, we'll import a number of libraries that we will use and print the TensorFlow version. You don't need to worry about the warning that you see here. Here you can see some images from the Fashion MNIST dataset. Loading it using TensorFlow datasets is easy. You just refer to its name right here. It will also split it into a train dataset and a test dataset for you. Let's load it. This step will take some time, and be prepared to do some scrolling. Alright, all done. As you can see, this dataset has numeric values for all of the different labels. It has t-shirt tops, sandals, and even ankle boots in it. Here we create a list to map the numeric value to a human-readable string. Let's now check the data. As you can see, we have 60,000 training examples and 10,000 test examples. Now we need to pre-process the data a bit. We do this by using this normalize function that we apply to each element of the dataset by calling .map. In the normalize function, we cast every pixel value to the float type. Then we normalize the pixel value range to be a number between 0 and 1 instead of 0 and 255. This is a very common technique in machine learning, and you can read more about it in the text below this video. And finally, we return pairs of images and labels. Here, we take the first example from the test dataset and plot it. That's cool! Now let's take the first 25 examples and plot their images. Super cool! Now it's time to build our model, like we discussed in the previous video. First of all, we flatten the 28 by 28 by 1 input image to a single one-dimensional array having 784 elements. Then we apply a dense layer with 128 neurons. To be able to classify Fashion MNIST well, we need to apply ReLU as the activation function here. And finally, the output is a dense layer with 10 outputs. This will be the probability distribution for the different clothing items, all summing to 1. We use the softmax activation function to create the probability distribution. Let's execute this. We compile our model using the Adam optimizer. We don't need to specify any learning rate, so it will use the default. Therefore, we can also use Adam as a string to the optimizer parameter. The loss function will be sparse underscore categorical underscore cross entropy. That's a really complicated word, but you don't need to understand what it is. You will always just specify it when doing classification. And finally, we want to see the accuracy metrics while we do the training. Let's compile the model. Now it's time to train our model. But before we do that, let's specify some iteration parameters to our datasets. The repeat flag here specifies that the dataset should iterate forever. The training termination will be determined by the epochs parameter to the fit method. Shuffle randomizes the order of all the examples. And batch groups 32 examples when doing the training. This significantly speeds up the training process. These are actually quite good defaults to use when you train any kind of model. For the test dataset, we only need to specify the batching. As usual, we train by calling the fit method on our model. Epochs is set to 5, and since we have 60,000 training examples, we'll train our model for 300,000 examples in total. The steps per epoch flag will soon disappear. You can always specify the following here. So now let's train our model. Okay, so the training is finished. You can see that we achieved 89% accuracy on the training dataset. Let's see how our model performs on the test data. For this, we use a new function on model called evaluate. this function evaluates the accuracy on the test dataset. And as you can see, it's pretty good, 88%. Now it's actually time to make predictions. So let's do that on a full batch, 32 examples from the dataset. Since we specified a batch size from the dataset, you can see that the predict call returned 32 answers, each with our probability distribution containing 10 classes. Here is the prediction for the first image. Can you see which class our model predicted? It's class number 6, almost with 90% confidence. We can use the argmax function on NumPy to print which index is the largest. We can use the argmax function on NumPy to print the largest index. So is this correct? Let's check the corresponding label in our test dataset. It's also 6, so it was correct. And as you may recall, index number 6 is a shirt. That's the core of classifying fashion MNIST. Now let's do some fancy plots. This is not mandatory to understand or to follow the rest of the course. First, we define some plotting functions. Then we look at the first prediction, the shirt. You can see the probability distribution across the classes in this bar chart. Now let's look at the 13th image, where the model correctly predicts is a t-shirt top with 54% confidence. You can see that it's quite indecisive and is also considering another class. Now, let's print 15 images, where the blue indicates a correct classification by the model, and the red an incorrect classification. Now, let's grab the first image in the test dataset. Then, let's add a dimension in front of the image itself. This is to create a batch of one image. Let's call predict on this batch with a single image. Again, this is a shirt with 90% confidence. And here we can see the probability distribution across the classes. And let's print the index using argmax again. And that's it for this collab. Now it's your turn to do some exercises right here. Good luck!